Smart dev. Okay, we can start again. And then I hope that will not happen again. Okay, we were here. We spoke about this, the properties of normal probability distribution, or the features. Okay? Now, that shape, the shape of a normal probability distribution, this one, it can be generated by this formula. We call it the formula for the normal probability density function. But you don't need to worry about this formula. We are not going to use it in our calculations. Just telling you that the normal, this shape of a normal distribution table, it's generated by this formula or some computer software. You can have, as long as you have, if you look at, let me just switch off my phone. If you look at the formula itself, okay. If you look at the formula, what you see here, we see pi, 2 pi, and pi is a number which is 3.14159, and e is also an exponential, is also a number which is also this one. Né? And this one here, this is our what? This is our mean. The population mean, it will be given. This and the standard deviation, these two would be given. This standard deviation, this standard deviation. So if you are good in math, or if you did mathematics, there's nothing difficult here because all the numbers are there. But like I said, we are not going to make use of this entire formula, but it's the one that can generate what we call the normal distributions. And once you do that, you plot it, then you can be able also to take any random variable, any value, any marks of student, then you can be able to find what is the probability that the student will score might be less than 50 or more than 50, or the student will score be above 70%. Okay? So this is the probability density function. Now, the formula that we are going to use is, we call it a Z distributions, where we are going to transform the random variables X into the standardized normal random variables, okay, by using this Z transformation formula. Remember, if you get the student, the marks of student, if you get 60 as a marks, or if you say what is the probability that the student will score above 60, so that 60 is now the X, or is a random variable. So we need to transform it to what we call the Z, or the standard normal random variable. This Z, we should be able now to read the probabilities from the standard table. Okay, from the Z distribution table. I think my laptop is affected by viruses. Okay. Now, what we need to know is that the random variable, you know, they are distributed between the mean and this mean and the variance here, or standard deviation, should be given to you. Now, converting this, the normal distributions, we should be able to get a probability between 0 and 1. Okay, the Z table has this property that is normally distributed with the mean 0 and the total probability equals to what? Equals to 1. So this is the formula that you are familiar with. I hope when you are doing your assignment, you have come across a formula like this one. Z equals to X minus mu over sigma. All right. Now, moving on, if you look at what we are interested in, we want to find the probability or the area under the normal curve, which is this. So which means now from negative infinity to positive infinity, and the point 0 there, the other side, like I said, is equals to what? 0. From this side, from negative infinity up to this point, the probability is equals to 0. Again, from this point 0 here, which is now, this is now your Z, all the way up to positive infinity, the probability that side is also equals to 0.5. Combining the two, 0.5 plus 0.5, it will give us 1. Okay? From negative infinity to positive infinity, the total area under the normal curve is equals to 1. So now, the probability is measured by the area under the normal curve. So we will do one example, and we will know how to plot or how to get a sections. Like if you're given a point A and B, this area is equals to what in terms of probability, or in terms of percentage from point A to point B. Let's say from 50 to 70. So in terms of probability, what is the total area between 50 to 70? So we should be able to make use of the other formula, then we can be able to get that probability. So let's do one example. Okay. So let X represent the time it takes to download an image file from an internet. So now X is a random variable, and that random is the time that it takes you to download an image from an internet. Okay, so which means it will even take, sometimes it can take 10 minutes, sometimes it can take 7, 8, whatever. So it's a random number. So you expect to get any number. So now previous information gives us that usually or normally it takes 8 seconds. This is now from based on the historical data or what is known. The mean is 8 seconds and the standard deviation is equals to 5, which means there are some variations there. Sometimes it's not always exactly 8 seconds. In some cases, it can be 10, it can be 15, it can be 4, depending on how fast your internet is. So what is provided here is now the random variable X, which is normally distributed. I don't know how to do this one, but our mean equals to what? 8, and sigma and sigma, right? We don't have sigma. I will use this one, but remember sigma is the other sign we will see on the solutions. So sigma in this case is equals to 5. So every time you are given a probability or this normal probability distribution, now the x is that picking any number, what is the probability that it will take less than 8.6 seconds to download? How do we find this probability that it will take less than 8.6 seconds? So let's see the calculations. The calculation, remember we use the Z, we use this formula. Let me clear all drawing, let me get rid of this. So remember, for this calculation, we have to make use of this formula, transforming that 8.6 to the Z by making use of this formula. This is 8, this is 5, this is 8.6. So it's just a matter of plotting that one into your formula, then you get a Z score. Call it a Z score. Okay, so the probability that it will be less than 8.6 is 8.6 minus 8 divided by 5. So we get 0.12. So now what we have done here, we have transformed this 8.6 into a Z score, which is 0.12. So what this formula does is just transform those numbers. Okay, so we are saying now, this 8.6 is the same as 0.12. We can't read this one from the normal distribution table, but we can read the other one. That's why we need to do the transformation. Okay, so now this number again, there are some rules attached to this. What you have to do that this number, the Z score, for you to be able to read it from the normal distribution table, it should be a 3 significant figure. So there must be only 2 numbers after the comma. Yeah? If it is 0.122, so you should round off to 2 decimal places all the time. If it is more than that, you will not be able to get the answers from the normal distribution table. So now to plot this one, remember the standard curve. The mean there equals to 0 according to this property. The mean is equals to 0 according to this property. Remember, this is the mean. It's transformed to 0. So the center point is at 0. Therefore, that's why you see here that on this plotting, we can find always 0 is there in the middle. And here you have negative numbers, and here you have positive numbers. Because sometimes if your mean is 50 and you have 40, which means you are in the negative, you are below average. You are on the below average. Now, if you look at this 0.12, we can plot it here on the normal curve. And what we are looking at a side or at an area which is less than, this one says less than 0.12. So 0 is less than, even this number, on this number line, you have -1, -2, -3, all the way up to negative infinity. So which means if you are to do your shading on the normal curve from this cutoff point, is this sectional area. So what is this area in terms of probability? You have already an idea, knowing that from this point, this red part, it should be 0.5. So it's just a matter of adding this 0.5 plus this blue part here. So this blue part plus 0.5, it will give us the area which is less than 0.12. Okay. Now, we need now to read this number or to get this probability from the normal, the standardized normal probability distribution table. This is just a portion that was extracted from the main table, But what it gives us, I'll show you later the main normal distribution. And that's the one that you need also to use when you answer your questions for the assignment. You need to come to the Z table and read those probabilities. And these tables are available on the internet. Okay. Now, if you look at this and you read this number here, our 0.12, the one that we have transformed. How we read that number? If we have 0.12, we need to split this number into two parts. The other part we can say is 0.02, and the other part is 0.1. Or we can start with 0.1, it doesn't matter. 0.1 and 0.what? Now, so if you look at this, it says we split that Z, this value, into two parts. So the first number, you see this number here? Hello? Are you guys here? Isabel?
Okay. Yes, I'm here.
If you look at this number 0.12, we split it into two. We say 0.1 and the other one is 0.02. So the first number is on this, the one that the number that goes down. So you have 0.1, remember you have 0.0, 0.1, 0.2, 0.3, all the way up to those small numbers down there. I'll show you the main table. And here you have 0.00, 0.01, 0.0. So now the 0.02 is here. Then you check where the two numbers meet, where they intersect. So that's the probability. But now if you look at this addition, the Z table does not give us the entire area. It gives us a section from 0 up to Z score. So it have only given us 0.0478. But knowing that the other part is 0.5, so we combine the two. And the probability that it will take less than 8.6 seconds to download an image from internet, it's equals to 0.5478 or 54.78%. And that's your conclusion. Okay. And if you go on the internet, there are some Z table that don't look like this one. Some table will give us straight this number. So but I would want us to make use for now to stick to the one that gives us this part from 0 to the Z score. And later on, when we will graduate to the other one once we are comfortable with everything. Okay, I want to show. Yes, you have a question? I don't know what is wrong with these things now today. Seriously. Now, I was trying to get the Z tables. These Z tables, they are misbehaving. They don't want to they are just black. They are no numbers. Okay. I hope this one will come out okay. But I don't want this one. Let me try to see if I can get another one. Yes. Okay, let me show you this one. This is the one that you will need to have. I will send it also on the group. This is the one that I want us to use. Remember the number that we were working with. It was 0.12. Okay. Then if you look at this part, we have 0.1 here. This 0.1, and we have 0.0. Okay, let me write it so that you can see what I'm talking about. So we have that number 0.12, and we split it into two parts. 1, and the other part is 0.02. So these numbers, I'm not getting them from my head. I'm just getting them here from this number, from this answer. 0.1, then once this number has been replaced, there remains a 0. You should split it into 2, yes? So now, if you split it like this is the first number, and this is the other number. Where they meet, this is the probability 0.0478. So that area, now you plot it on the normal curve. Then you add the 0.5. Because it says less than. Okay? So this is the table that you will be using. Okay, let's go back to another example. Another example is this one. Find the probability that it will be greater than 8.6. Remember, this is an area greater, means it should, it's an area under the normal curve, and greater than means from that point to your right. If it says greater, which means it's from this cutoff point 8.6 to your right, because when you are moving to your right, which means you are moving to the positive side. If it is less than, it's from this point to your left, which means you are moving to the negative. So now to do your calculations, just you know that the question is based on the mean and the standard deviations. And this is the random variable picked. You plot it. Remember, this x is always what is in question. And this one remain constant throughout the question. So 8.6 minus 8 divided by 5, we get this one. That's the answer. It's still the same number, but now the shading or the area of interest now is on your right side from 0.12 up. That's the part. So going to your normal table, because this is now to your right, that's why we are shading that part. The other part, the other question we were saying to the left, can you see that it's shaded to the left? But now this one is bigger because this number was on the other side of a 0. But this one is now smaller. So we expect this probability to be very, very small. So let's look at this. Go to your normal table, still you will get this number. Can you see this? Hello?
Yeah.
So we are still getting the same number, but now this number said it belongs from 0 to the z-score. Can you see these 2 arrows here? Down here? So this probability is between 0 and 0.12. But we are not interested in this area. We are not interested in this area, though from the table we are getting that probability. So that's not the final answer. It's just the probability that we get from the table. Now we are looking on the upper tail. Is your right here, but we did not get the red part. So what we can do, we can take the 0.5. We know that this whole area is 0.5. So we take the entire parts minus this portion to get the other one. It's like, how do you fix things that are, what is it? If you have something, let me say, part that you want to take to fix together. It was a complete part, but now this is another part that has been removed. So what we are doing here, we are just trying to complete this part. So how do you, if you are given this, let me make use of this example, a ruler, for example. If you have a ruler is something which is a triangle like this. You know, this is one ruler, or we can say this ruler represents 0.5. We are saying this ruler here is not a complete ruler. There's another part So this now we have half of a ruler, which is now, we can, if you have half of a ruler, then you can say this is what? 0.5. A ruler comes, is from there up to there. But if you have half of it, which means you have 0.5. Now, in this case, we are saying now the ruler is reading somewhere, somewhere at 0. What? This is a 0, this is 0. What? 0.12. Now we only have what we get from the table, we are getting this part only of a ruler, of which we know the ruler is what? 0.5. But the question is not interested in this part of a ruler. We want the other part. This question is looking for the other part, but the table gives us this part. So what can we do to get the other part? So imagine if this one was not there. So we can say we know a ruler is 0.5. That's why we are referring to that point that this is 0.5. So we can say the entire ruler, or the entire half of a ruler, which is 0.5, minus this portion here, it will give us the other section. You understand that? So it's the same concept. You can apply the same concept that if from the table we are getting this area here, of which we know from this part all the way is 0.5. We can take 0.5, that half, minus this section that we don't want, even though we are getting it from the table, so that we can get what we want. So that probability is 0.4522. I hope that is clear. No? So, but now if you have the entire ruler is 1, which means this whole section is equals to what? To 1. So if you want to get this, let's say, if you want to relate, if you say 1 minus, just take 1 on your calculator. I hope you have a calculator. Okay, just take 1 minus 0. This one. Calculate that one. Just say 1 minus 0.0478. See what you will get. What are you getting? Hello?
Just a second.
Okay.
You
Just
said you said 1 minus 0.
No. Say no. Listen.
0.48.
No. Hello. Just say 1 minus 0.4522. So what are we getting? We are getting 0.55478, isn't it? So which means we have taken the entire curve 1 minus this part. So that probability of 0.5478 is the other part. Again, if you say 0.5 plus this, it's still going to give you 0.5478, isn't it? If you say 0.5 plus this one, it's still going to give you 0.5478. So that concept of 1 now you understand. Okay, and if you look at that answer that we got then, and you go back to the first example, You see this part here. Remember, we are using the same number. You see this number 0.54 is this part. And if you use the concept of 1 again, you get this same number to represent that shaded area for the less than. Okay, so please make sure that you understand the table, understand why are we using 0.5, why in some cases we have to add, sometimes you have to subtract. And you need to understand how to read the table. If you don't understand how to read the table, you will never, you will just end up maybe at this number. Coming up to 0.12 is very easy, but the problem is reading from your table, because you need to understand how to read the table. Now let's look at the last, this is the last part that I will do for the in-between. Because sometimes you want to find what is the probability that the mass can be between, or the time it will be between 8 seconds and 8.6. Or you want to find maybe what the probability that the student can score between 60 and 70. Okay, you want to find that probability. Now, since these numbers, there are two, it's very simple. Just take the numbers, you plot them, or you put them into the formula. Okay, between 8 and 8.6. So we can say 8 minus, so this one is 0. No? Because the random, so it's 0.00. Then 8.6 is 0.12. The good thing about this example is just because we have already the answers. We have the answer, we know already 8, 0.12, 0.04, 0.0, what is this, 0.0478. So now we have transformed 8. Remember, it's a transformation. 8 has been transformed. You see, 8 has been transformed to what? To 0, because 8 minus 0 divided by 5 is 0. 8.6 has been transformed to 0.12. So this is the same as this. If you do the plotting on the normal curve, if you plot this and this one, the area is equal. Only the numbers that differs. Okay? Now we know. Now we go to the table. 0. If you get a 0, which means that probability is also equals to 0. No? 0.0. So we are looking at 0 is just 0. But the other one is 0.0478. So we have this one. Again, the area between 0 and this, 0 and 0.12 is 0.04. We don't need to subtract here because this is what we are looking for. This is what we are looking for. Between 0 and 0.1. Again, let's look at this one again. This is another example. What is the probability that it will take 7.5 to 8 seconds to download an image from the internet? So you plot that one, 7.4 to 8. Yes, sorry for the interruption there. It was the internet, but we are here again. So between low, so we are saying between 7.4 and 8. So we say 7.4 minus 8. Remember, these 8 and 5, they are constant. Here we are getting negative. Negative 0.12 to 0. This is similar to the other one, only that now you are on the left side of your normal curve. The probability will remain the same here. You are on the left. In the previous one, we were on the right. Can you see my screen? So you were on the right area, or the distance remains the same. So the probability, remember, even if you're getting a negative, this, remember, a Z value can be negative, it can be positive, it It can be 2, it can be 3. Ne? But the probability should always be between 0 and 1. It's a final answer. If you give an answer which is not a decimal or beyond, or which is negative, then that's an incorrect answer. So it's 0.0478, our answer. So it's the same property then. Now, there's this another example. I want you to do this example. Yeah? I want you to do this example. So let me just read it for you. There's also some activities. Yeah. This one, I want you to go and do this activity. And, make sure, okay, let me discuss with you this example number 2. Weekly purchases of petrol at a garage are normally distributed with a mean of 5,750 liters and a standard of 2,525 liters of petrol. So which means if you go at the service, then you fill your cars, there are some record that has been recorded by the service stations where they have indicated or captured that on a weekly basis, the average liters that are purchased at that service station every week is 5,750 liters. That number is possible because if there has been in operation for some time, they have historical data, and they should be able to calculate the mean or the average. And based on their calculations, they have come to the conclusion that the mean on the weekly basis is 5,750. This is an estimate, with some variations. Variation, which means it does not have to be always 5,700 liters, but it can either be in some cases 5 or 6,000, 7,000, can be 4,000, but the center point of the likelihood that it should surround this number, somewhere close to this number. It should not be 11,000 liters. It's not possible. Because if it is 11,000 liters, it's no longer normally distributed. So there are some variation in this standard deviation, which means it can be plus minus, maybe with some variance of 2,525. So that's the range. Now the question is, any week, picking any week, what is the probability that the purchases of liters will be less than 4,875 liters, or the liters can be more than 3,760 liters? Can you answer this question, please? Who is cooking? You must give us food.